Hello my dear learners, welcome to my course on energy sources. In this today's sessions, I will be talking about the formation of steam. I am Shamant, currently working as an assistant professor at Global Academy of Technology in the Department of Mechanical Engineering. And if you want to reach out to me, you can mail me at shamant@gat.ac.in. So you all know that all the substances under certain conditions of temperature and pressure, it can exist in one of the three states, which is solid, liquid and gas. So you know these are the three states of matter: solid, liquid and gas. And moving on further, there is plasma state, all those things, but we are not concentrating on that. But the majority of the matter, what we can see is in the three forms, that is solid, liquid and gas. But there is only one substance which can exist in all the three phases of matter, that is water. If at all you freeze it, it becomes ice, that is the solid phase of the water. Then if you heat the ice, it becomes water, which is nothing but the liquid phase of the water. And then if you heat it further, it turns into a vapor, that is gaseous phase. So that is why this is very important substance. And water, which is liquid at normal temperature, it begins to boil to form the steam when you heat it sufficiently. Okay, that is when it reaches gaseous state. And then if you are refrigerating it, it converts into ice, that is solid state of water. Initially it is found in liquid state. Okay, in practice, steam is generated in steam generators, or popularly known as boilers. You all have understood two types of boilers. One is fire tube boiler and then water tube boiler. So based on that, why that boiler is very much important to generate the steam, and how is that steam generation takes place is what we will be understanding in this lecture. You need to understand that there are three types of steam, or you can also call it as condition of steam. The first type of steam is wet steam. The second one is a dry steam. The third one is a superheated steam. You need to understand when it is called as wet steam, when it is called as dry steam, and when it is called as superheated steam. So we'll see the definition of a wet steam. Wet steam is defined as two-phase mixture containing saturated liquid and vapor which is formed at saturation temperature. This is very much important. So when is the wet steam available or obtained? It is obtained when the saturation temperature of the liquid is reached. Okay, there is a saturation temperature. You will understand what is saturation temperature. So a wet steam is the combination of saturated liquid as well as the vapor which is formed at the saturation temperature and at a given pressure. So we call wet steam as a two-phase mixture. It is a two-phase mixture. Why do we call it as two-phase? Because it has liquid as well as vapor. So this wet steam which formed contains small water particles held in suspension that has not yet absorbed and the latent heat and evaporated. It has not yet absorbed the latent heat and it has not yet evaporated completely. It is still at a stage of boiling. So saturation temperature is that temperature of the liquid or a substance where the liquid starts to boil. Okay, it is not completely converted into vapors. It has just started to boil. When you heat the water, when you keep it on a stove and then when you heat it, what happens? At one particular point, it starts to boil. That temperature at which it starts to boil is called as saturation temperature. Okay, and the wet steam at the saturation temperature, if the steam contains liquid and as well as the vapor, then you call it as wet steam. Next is dry steam. It is a pure steam that does not contain water particles in suspension. When the water is completely converted into a steam, when there is no water particles in suspension, it is completely dry, then only you call it as dry steam. It exists completely in pure vapor form at the saturation temperature and at a given pressure. So you can ask me, even the wet steam is obtained to us at saturation temperature, and even the dry steam you are saying that it exists completely in pure vapor form at the saturation temperature. You might have a doubt. Your doubt will be clear in the next slides. So as of now, you just understand what is dry steam. Dry steam is nothing but it is a pure steam which does not contain water particles in suspension. The third type of steam, what you can see, is superheated steam. It is represented by T suffix SUP. SUP stands for superheated. Okay, superheated temperature. Superheated steam is defined as the steam that is heated beyond the dry saturated state. That means after you get dry steam, if you further heat the dry steam beyond that particular temperature, we get the dry steam at a saturation temperature. When you heat it beyond, then the temperature will be definitely higher than the saturation temperature and also pressure at a given pressure. So here the temperature and pressure starts to increase. So that state of steam is called as superheated steam. It is that steam which, when it is obtained only when it is heated further after achieving dry steam. That is what your understanding should be. Now, what are the characteristics of the superheated steam? Why do we prefer superheated steam? Okay, in boilers, the main function of the boiler, or the main aim or principle of a boiler, is to find out the superheated steam, or to produce the superheated steam. The characteristics of a superheated steam is the heat content of superheated steam is very high, and hence its capacity to do work is greater. Why only superheated steam is chosen for production of power is because the heat content is very high. When the heat content is very high, the work done on the turbines is very high, and its capacity to do work is greater. So this makes it to use for power generation. Due to the high temperature, superheated steam gives high thermal efficiency. Important point. It gives high thermal efficiency, and it minimizes the specific consumption of steam when used in the turbines. So that is the reason superheated steam is used in power production. As there is no moisture content in superheated steam, erosion or corrosion of turbine blades are minimized. When there is water content, there are chances that turbine blades might rust, or the casting or the enclosure might have some of the rust. So because of that, the whole turbine might fail. So what we do is we use superheated steam where the erosion or corrosion does not take place. It is completely minimized. That is why superheated steam is chosen than the dry steam and wet steam. So to understand the formation of the steam, we will have to do a small experiment. And the experiment is like this. You have to take a cylinder. This is a cylinder. And the cylinder should be fitted with a piston. You have a piston here. And above the piston, you keep a constant weight W. Okay. So you are taking a cylinder. Inside a cylinder, you know there will be a piston which moves to and fro. And then over the piston, you are keeping a weight W. And before that, when you just open the cylinder, fill the cylinder with water of volume Vf. Cylinder is filled with a water of volume Vf, and water is generally taken at 0 degrees Celsius, and then you close the piston. Above the piston, keep a weight W. So this is what you have to do. And then after it is taken in the cylinder, you start heating that. You have to apply external heat. External source of heat can be used. You are applying the heat to the water which is filled inside the cylinder, and slowly when the water is heated, it gradually increases the stages. Here these are the 5 stages of what the water reaches. I will tell you what are these stages, but as of now, in the first case, you have to just understand that the experiment is being done, and that experiment is to heat the water which is contained in the cylinder fitted with a piston and an external weight W. Why are these external weight W and piston are over the water? To exert a constant pressure P completely throughout the experiment. That is the reason. And Vf is the initial volume of the water. There are certain other terms that we are using, and that is Ts, which is nothing but saturation temperature, TSUP, which is nothing but temperature of a superheated steam. Then Vf is the volume of the water. Then Vg, you will be finding Vg here. So this is the Vg, and that Vg, here you can just see, this is the entire volume of the steam generated. Okay, that is Vg. It is volume of dry and saturated steam. VSUP, you will be getting VSUP at the last stage, and this is called as VSUP, and VSUP is nothing but volume of a superheated steam. So this is the initial explanation for the experiment that I have done to you. We will see what exactly the experiment is all about. So you are taking 1 kg of water at 0 degrees Celsius, which is taken in a cylinder. I explained you all this in the previous slide. In a cylinder fitted with a freely moving piston, a weight W is placed over the piston. The weight of the piston and the W which is placed over the piston exerts a constant pressure P on the water. And V is the volume occupied by the water in the cylinder. We have denoted it by Vf. Okay. Now you have to heat it. You have to start heating the water which is filled in the cylinder. When water is heated, the temperature of the water slowly rises. From 0 degrees Celsius, it starts to achieve 5 degree, 10 degree, 15 degree. It slowly rises, and at a certain temperature, water begins to boil or evaporate. Water is now starting to boil or evaporate. That temperature at which the water starts to boil is known as saturation temperature, and it is denoted by Ts. Okay. At this temperature, there is slight increase in the volume of the water, Vf, as shown in the figure. This is the temperature enthalpy diagram of the formation of steam. Water which is taken in the cylinder, which is filled inside the cylinder, is at 0 degrees Celsius. It is at point A. Now what you do at the first stage, you start heating the water and the water starts to boil. It slowly raises its temperature from 0 to 5 to 10 to 15, so on. And at one point it reaches this point B, and this point B is the point at which the water starts to boil or evaporate, and that temperature which you get is called as Ts. It is nothing but the saturation temperature. This is temperature versus enthalpy diagram. In the y-axis you have temperature, in the x-axis you will be having enthalpy. I'll come to enthalpy when I explain you about the properties of the steam. Enthalpy is nothing but the internal energy, or it is the heat that is required to raise the temperature of the water. As of now, you just understand. Okay, the heat which is required to raise the temperature of the water is called as enthalpy. So now you have understood that from point A, the water has reached point B, which is nothing but saturation temperature, and the heat required for the water to raise the water from 0 degrees Celsius to saturation temperature is called as sensible heat. Okay, sensible heat is the heat which is required to raise the water from 0 degrees Celsius to Ts, that is sensible heat, denoted by Hf. Now you can see that at stage 2, the water has slightly increased. When the water reaches Ts degrees Celsius, the water has been slightly increased. The volume has been increased now. So that is what you can see here. In the stage 1, it was Vf, and slightly it has been increased. It is not increased much, but it has reached stage 2. Now from stage 2, it should go to stage 3. Now the water is at saturation temperature. When the water is heated beyond the saturation temperature, there will be no rise in temperature, but evaporation takes place. At this stage, water exists as a two-phase mixture, which is containing saturated liquid as well as water vapor, occupying the volume Vfg as shown in the figure C, or the third stage. The steam in this condition is called as wet steam. So now water, after it is started to heat further from Ts degree Celsius, it has been increased further, the temperature has been increased. So part of the water has been converted into steam. There is some amount of water which is still left in the cylinder, which has to be converted into steam. So you can see the increase in volume here. The volume has been further increased. So that is what the further heating does to the water. So when you heat it further, the evaporation of water continues at the same saturation temperature until the whole water is completely converted into steam. This process is indicated by the line BC in the TH diagram. So this is where the line BC in the TH diagram represents. So at B, the water has attained its saturation temperature. The water has just started to boil, and from that particular state to point C, it gets completely converted into steam. So in between, the temperature is further increased, but even though heat is applied, the temperature does not rise. So it remains at the saturation temperature. That is why it is represented in the horizontal line. At the point C, the steam is completely converted into a dry state. Okay, so you have understood from A to B what happens, from B to C what happens. From BC, the enthalpy, okay, so it is called as HFG, it is denoted by HFG, and HFG is nothing but the latent heat. It is the amount of heat which is required to convert the water at saturation temperature to a dry state of steam. That is what latent heat of vaporization is. Now from stage 3, the water is being further heated, and when it is further heated, the water in the cylinder completely gets converted into a dry saturated steam. So this is the steam that you get at point C on the temperature enthalpy diagram, and the volume obtained by a dry steam is denoted by Vg. Vg is the volume which is occupied inside the cylinder by a dry saturated steam at point C on the TH diagram or temperature enthalpy diagram. So at point C, the steam formed does not contain water vapor, and hence the steam in this state is called as dry steam or dry saturated steam. The volume occupied by the dry steam is Vg, as I showed you on the figure number 4 in the experiment. Okay, so the volume occupied by the dry steam is denoted by Vg. Now you will not stop at point C once you get the dry steam. What you do is, if heating is continued further at point C, the temperature of the steam increases above the saturation temperature. From point C, it will not remain horizontal. The temperature will start to increase, and above the saturation temperature, the temperature whatever you get is called as superheated temperature, and that is denoted by TSUP. The steam in this condition is called as superheated steam. This process is shown by the line CD on the TH diagram. VSUP is nothing but the volume occupied by the superheated steam showed in the figure. This is the temperature enthalpy diagram. You get dry saturated steam at C, and at C the volume occupied by the dry steam is shown in the figure as Vg. And now from this state you start to heat further. When you heat further, it reaches a different temperature state, and that temperature which is represented as TSUP. TSUP is nothing but the superheated temperature, and the volume occupied by that particular state of steam is called as volume of the superheated steam, and that is represented in the figure in stage number 5. So this is the last stage. So after you get dry saturated steam, you heat further. When you heat further, the heat is added, the volume of the steam reaches superheated volume, okay, VSUP, and the temperature further increases, pressure also increases. So the substance inside the cylinder, which is nothing but the steam, it increases further, and the volume is increased from Vg to VSUP. So volume has been increased. So you can see the conversion of water from Vf, which is taken as the liquid in stage number 1, to stage number 5. So this is how the water is converted from liquid at 0 degrees Celsius to the steam at the last stage. So this is how the water is converted into a superheated steam. We will not prefer dry saturated steam because the thermal efficiency is lesser when compared to the superheated steam. So the amount of heat required to raise the water or raise the steam which is at point C to point D is called as enthalpy of superheated, the enthalpy of a superheated or superheated enthalpy, and that is represented as CPS into the difference of superheated temperature, that is TSUP, the difference of superheated temperature to the saturation temperature. When you take the difference, you will be getting the enthalpy, and that is nothing but the enthalpy of a superheated steam. So you can just see the abbreviations given here. HF is nothing but the sensible heat. Sensible heat is the heat required to raise the water from 0 degrees Celsius to the saturation temperature. Latent heat is the heat required to convert the water which is at saturation temperature to a completely dry state at C. Then HSUP is nothing but the enthalpy of a superheated steam, that is represented by CPS into TSUP minus TS, where CPS is nothing but the specific heat. And then you have to take the difference between the superheated temperature as well as the saturation temperature. So this is about the formation of steam. I hope you have understood the formation of steam very well. Thanks for listening. If you like this lecture, Please share it among your friends, like it, and do subscribe my YouTube channel. Thank you very much.